Coding and Programming Crash Course, Object-Oriented Programming, OOP. Introduction. Object-Oriented Programming, OOP, is a powerful programming paradigm that allows you to organize your code into objects, which are instances of classes. It provides a structured approach to software development by emphasizing modularity, reusability, and encapsulation. In this crash course, we will explore the concepts and principles of OOP and how they are applied in various programming languages. Interesting stories or examples. 1. The blueprint of a house. Imagine you want to build a house. Before construction begins, an architect creates a blueprint that outlines the structure, design, and functionality of the house. The blueprint serves as a template for building multiple houses with similar characteristics. In the same way, a class in OOP acts as a blueprint for creating objects with predefined properties and behaviors. 2. The animal kingdom. Consider the animal kingdom, where animals can be classified into different species based on their characteristics. Each species shares common attributes and behaviors. For example, all mammals have properties like fur and the ability to nurse their young. In OOP, you can create a class called mammal that defines these common attributes and behaviors. Instances of this class, such as dog or cat, inherit these characteristics and can have their unique properties as well. 3. The online shopping experience. When you shop online, you interact with various objects like products, shopping carts, and payment systems. Each object has specific attributes and behaviors. For instance, a product has a name, price, and description, while a shopping cart can add, remove, or calculate the total cost of products. OOP allows you to model these real-world objects as classes, making the development process more intuitive and efficient. Top 12 popular OOP principles. 1. Encapsulation. Encapsulation is the principle of hiding the internal details of an object and exposing only the necessary information. It promotes data integrity and prevents direct access to internal data from outside the object. 2. Abstraction. Abstraction focuses on simplifying complex systems by representing the essential features and hiding the implementation details. It allows you to create abstract classes or interfaces that define common behaviors without providing specific implementation. 3. Inheritance. Inheritance enables the creation of new classes, child classes, based on existing classes, parent classes. It promotes code reuse and allows child classes to inherit properties and behaviors from their parent classes. 4. Polymorphism. Polymorphism refers to the ability of an object to take on many forms. It allows objects of different classes to be treated as objects of a common superclass, providing flexibility and extensibility in code design. 5. Modularity. Modularity promotes the decomposition of a complex system into smaller, manageable modules. Each module represents a distinct functionality or a specific object, enhancing code organization and maintainability. 6. Encapsulation. Encapsulation is the principle of bundling data and related behaviors together into a single unit called an object. It allows for better code organization, data protection, and code reuse. 7. Cohesion. Cohesion measures the degree to which the elements within a module or class are related and work together to achieve a common purpose. High cohesion indicates a well-structured class with focused responsibilities. 8. Loose coupling. Loose coupling refers to designing classes or modules in a way that minimizes dependencies between them. It allows for better code maintainability and flexibility by reducing the impact of changes in one module on other modules. 9. Dependency injection. Dependency injection is a design pattern that enables the decoupling of components by injecting their dependencies rather than hard-coding them. It promotes modularity, testability, and flexibility. In code. 10. Single responsibility principle. The single responsibility principle, SRP, states that a class should have only one reason to change. It promotes code modularity and maintainability by ensuring that each class has a single, well-defined responsibility. 11. Open-closed principle. The open-closed principle, OCP, states that software entities, classes, modules, functions, should be open for extension but closed for modification. It encourages the use of abstraction and inheritance to extend functionality without modifying existing code. 12. Liskov substitution principle. The Liskov substitution principle, LSP, states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. It ensures that subclasses adhere to the contract established by their superclass. Summarize. In this coding and programming crash course, we explored object-oriented programming, OOP, and its key principles. OOP provides a structured approach to software development by organizing code into objects, classes, and hierarchies. The principles of encapsulation, abstraction, inheritance, and polymorphism play crucial roles in OOP and help create modular, reusable, and maintainable code. We discussed interesting stories and examples to illustrate the concepts of OOP, such as using blueprints to build houses, classifying animals based on species, and modeling online shopping experiences. Additionally, we listed and described the top 12 popular OOP principles, including encapsulation, abstraction, inheritance, polymorphism, modularity, cohesion, loose coupling, dependency injection, single responsibility principle, open-closed principle, and Liskov substitution principle. Remember, mastering OOP principles and practices takes time and practice. As you continue your coding journey, make sure to apply these principles in your projects and explore real-world examples to deepen your understanding. Poem. In a world of objects, code comes alive. With OOP principles, we let it thrive. Encapsulation, abstraction, and inheritance too. Polymorphism and modularity, a powerful brew. From blueprints to animals, stories unfold. OOP's magic, a tale to be told. With code as our canvas, we build and create. An elegant solution, a masterpiece, innate. Single responsibility principle, a guiding light. Open-closed principle, keeping our code tight. Liskov substitution principle, harmony it brings. In the world of OOP, where innovation sings. Song. Verse 1. In the realm of code, where possibilities lie. OOP is the language that helps us fly. Encapsulation wraps our data so tight. Abstraction simplifies, makes everything right. Chorus. OOP, OOP, the way to code. With principles guiding, we'll never be slowed. Inheritance and polymorphism, oh so grand. Modularity and cohesion, hand in hand. Verse 2. Loose coupling and dependency injection. Building systems with flexibility as the projection. Single responsibility principle, each class in its zone. Open-closed principle, extendable to the unknown. Chorus. OOP, OOP, the way to code. With principles guiding, we'll never be slowed. Inheritance and polymorphism, oh so grand. Modularity and cohesion, hand in hand. Bridge. Liskov substitution principle, maintaining the flow. Objects interchangeable, where elegance will show. Together they form the foundation strong. OOP, a melody in our coding song. Chorus. OOP, OOP, the way to code. With principles guiding, we'll never be slowed. Inheritance and polymorphism, oh so grand. Modularity and cohesion, hand in hand. Ending note. ******, start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?aid equals 7989335. It is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for your kind support of our AnHub Metaverse channel, and please subscribe and watch more interesting videos here.